Okay, so let me start up by basically introducing what a system design round is typically in an interview as such. I'll basically talk about that. Then we'll probably do some basic oops so that everybody's up to speed and things which we talk about here is understandable by most of the people. So I'll just cover basic oops. I'm not going to go deep into it, but I'm just going to cover basic stuff. And then probably we can move to the S.O.L.I.D principles as such. Okay. So in a typical interview, and this depends on your years of experience as such. In most cases, and I'm going to generalize this a bit. So in most cases, you'll find that if you're below 3 years of experience, probably you won't have a system design round. In most cases, I would say, at least in the MNCs or the bigger MNCs or I would say the top 4 companies, probably you'll not have it. But people who are 3+ years of experience would have it. In case of startups, there might be a bit of exception. So you might have a system design round just to see how good you are, even if you have three less than 3 years of experience. Okay. Now, basically, the way your experience grows, right? If you move from 3 to 5, probably there's a certain expectations about your system design rounds. If you move from 5 to 7, probably the expectation will change a bit. You will expect you to do more things or give more in-depth answers. And when you move to 7+ and things like that, or 10+, probably the expectations it will change a lot as such, I would say. So keeping that in mind, probably keeping that in mind, probably system design is something which everybody should know, at least because if you start off early, if you start understanding it early, if you apply into your day-to-day work, you'll eventually get better at it. And slowly, when you improve and once you appear for interviews and going forward, you will have a better chance of cracking it, I would say. Okay. Now coming to the system design part. So there are generally 2 kinds of rounds for system design. One is called as a low-level design. The other is called as high-level design. Okay. So in low-level design, you would basically find that the interviewer basically wants you to code out a scenario. So in general, they would want you to have some diagrams, build out some diagrams, some UML diagrams, some interaction diagrams, some component diagrams, things like that. And after that, they would also expect you to code out the whole thing either on paper or on a machine as such. So LLD rounds, I would say, differs a bit in some cases. In some cases, people would want you to just it might be paper coding round where people would ask you to basically tell you how the classes would look like, what different classes you'll have, how the interaction would happen between them, right? And then there is other piece in which some companies would want you to code out a certain scenario end to end as such. So, I mean, just take it for example, like a cab aggregator system or something like that. In that case, they would want you to build out the whole system. Not build out the whole system as such, but they would want to have a basic functionality. So they give you a list of certain functionalities, and they would want you to basically code it out. And they would want basically a running output, I would say, in those cases. But yeah, it does differ a bit, but on the top level, it remains the same. So low level is basically about more detailing as such. So in depth of what are your classes going to look like? How are these classes going to interact with each other and things like that. Okay. Then the other piece is the HLD part. Okay. Now moving to the HLD side of things. So high level design is more of I would say 100 feet view. So you can think of this as when you're trying to build out a system, you don't go into the deeper details as such. So you're not going to talk about the classes which you're going to have, but you're going to talk about different components which you're going to have, right? So think of this, that if you're building a web-based applications, you might have a load balancer, you might have some microservices, you might have some databases or some caches which would interact with those microservices as such. So when you're trying to build out these kinds of systems where you are giving a high level understanding, you're basically telling the interviewer of these are going to be my high level components and this is how it's going to interact with each other with some the request flows, the response flows, how which database would you use, what caches are you going to use, what eviction policies of the caches you want to have. Do you want to build, do you have a messaging set up somewhere? Do you use queues and things like that, right? So it's basically about a high level view of your whole system. So what are different components? How do those components interact with each other? But you don't go into the inside details. Like you're not going to talk about that this microservices is going to have these classes and this is how your class would look like and things like that, right? So you leave out the detailing stuff, I would say, on those levels, but you will have like a high level thing defined as such. In some cases, they would want you to build those high level APIs. So they, in case of REST or gRPC, depending on what kind of services are you going to build, in REST, they would want you to define some REST-based APIs, so how the endpoints are going to look like and things like that, right? So depends on what kind of application you're building, right? So yeah. So in general, if I would want to say, like, if you're talking about low-level LLD kind of around, low-level design kind of around, so think of this as more detailed thing in which you're gonna explain about the classes and the interactions and things like that. And on the high-level design, it's gonna mostly be on a more, I would say, abstract view or a top view as such. And this is gonna talk about different components which you have as such. And you can treat the components as the microservices, the load balancers, databases, caches, and things like that. Okay. Okay. So somebody's asking about what for freshers. Yeah. So once again, there are too many questions. How do you handle a case when you have user experience in another domain? Okay. So just give me like I'll take a few questions. So about the fresher thing, right? So one like think about this, like when you're starting off as a fresher, right? I mean, in the particular industry, people know that you're getting out of college right now. You don't have a lot of working experience as such, right? So they don't expect you to be too fluent on the design aspect. A lot of companies will not even interview on the design aspect as such, right? So that's the case. But in general, if you think about this, they will more be focused on your, I would say, DSA part. I would say you will have like multiple rounds or 3 or 4 rounds, but they will highly be concentrated on the DSA rounds as such. And even if they have a design round, probably it's just to see on like how good you are at doing stuff. Probably it might not be a deal breaker as such. Okay. Yeah. Okay. Another question. Yeah, so I would say probably in the interviews, not a lot of companies will look for a lot of experience in system design for freshers. But I would say you should do that because our industry is changing a bit. So when I started off, people who had like 5 years of, like 5+ years of experience were generally asked about designing and like the design questions as such. Now I've seen it has dropped to 3+ years. Probably a few years down the line, it might be like 1 year or something like that. Yeah, how system design interview would be. Do you need to prep for system design interview for 1 year experience? For yeah, so for the top 4, I think for with 1 year experience, probably they're not gonna ask you system design rounds. And even if they're gonna ask you, there's not a lot of weightage as such. I've not seen it too much for like less freshers experience as such. Okay, I see. I'll pick one more question from the experience side. People are asking about how do you do it when you want to change domains as such. Yeah, so I would say like it depends on the kind of domain which you want to go in. If it's a very specific domain, they'll probably require knowledge in the specific domain as such. But if you look at other domains as such, for example, if you're gonna go for a top 4 company there, I don't think so they care too much about the domain you're coming in. So even if you're from a different domain, it's just that if you know your basics well, if you're able to answer properly in those design rounds, you probably should be good. So you don't require a lot of domain knowledge in that. But then there are companies who have, like I would say outside of the top 4, who don't hire generalists, who are hire specialists as such. For example, if you are somebody who's into the blockchain or things like, or if you want to apply for a blockchain company, probably they would require some experience which you have on blockchain and things like that. So yeah, that's it. Okay, somebody says that can you please share the meeting agenda? What will be covered in this meeting? Okay, so yeah, in this, basically this is a webinar for S.O.L.I.D principles. So I'm gonna start off with some basic hoops, I would say, and then we'll move to the S.O.L.I.D principle as such. The reason for starting basic hoops is I just want to see, or I just want to take care of it. Everybody knows about, like, has some understanding of the basic hoops, because I see a lot of freshers on this call, so I don't want them to get lost when we're talking about a few things. Okay. Yeah. Okay. So I hope everybody can see the presentation. If you just put it on the chat, if you're able to see the presentation. For OOPS, like the basic structure of OOPS, or the most like talked about part of OOPS, is objects and classes. So what is an object? Basically, an object is any real world entity, I would say. And you can think of, like, if in real world I want to talk about anything, you can just say everything is an object, right? So a window is an object, door is an object, humans are object, right? So anything, a runtime entity which you can create out of a program, you can call this as an object. A class is basically like a blueprint. So you can think of this as like animal can be a class, and a dog, which is an object of an animal class, can be an object as such, right? So if you think about this, class is basically like a blueprint in which it provides initial values, and then it has like, so these initial values can have some states. For example, you can have states like a human would have legs or things like that, right? So, okay. Okay, so you can think of class as a wrapper or as a blueprint, which has certain states. And the states can be things like, okay, so example, if I have a class as human, the states might be like, I have like number of hands, or number of hands, number of feet, and things like that, right? So I can have some states as such. And then I could have some behavior. And the behavior could be basically represented by some member functions or methods as such. So you could have things like a human can speak. So can speak might be a behavior, or can talk might be a behavior, and they can walk can be a behavior as such, right? So if you think of this on the top level, you can think of this as a class as a blueprint. And this, out of this blueprint, right, I can create objects. So I can create a human being object, and I could name this as Ajit, and I could have some like, I could assign them certain states and things like that, right? So I could say that, yeah, Ajit has 2 feet, has 2 hands, and can walk, something like this, right? So we are able to basically encapsulate all of these things into one particular unit as human, and use that to represent something. Okay. Okay. Now there are some principles for OOPS, and we're going to discuss this one by one. There are basically, I mean, on the top level, there are 4. It's called encapsulation, abstraction, inheritance, and polymorphism. We're going to discuss this one by one. Yeah. Okay. So I think probably let's start with encapsulation first, and then come to this. Yeah. So you can think of class as a basic, like an encapsulation, right? So what I'm trying to do is, I'm saying that, okay, I'm encapsulating, or I'm basically wrapping some properties and certain behaviors into a particular class, right? Yeah. So in encapsulation, what you do is you wrap the whole states and behaviors into a single unit as such, right? So I could say that this class actually encapsulates a certain kind of data and behavior, right? And then if you look at this, you can basically think of this like, there are certain behaviors which you want, like, from the outside world to be visible, and then there are certain behaviors which you not want to be visible as such, right? So for example, if I, for some reason, I'm going to create a class which has like 3 public functions and 2 private functions. What I'm trying to do is, I'm saying that these are the 3 public functions, or these are the 3 functions or behaviors which somebody from the outside world can see or can use it. But these 2 behaviors, which are the private functions, which are not visible from outside as such, right? And in general, what we do is, while creating a class, we would try to keep all the states or the instance variables as private, so that nobody can outside from directly access it. And at the same point of time, I could basically define what is getting used from the outside world, right? So I can use it to hide something. So I would say that, okay, I don't want to reveal this property from outside, so I'm just going to hide it from like the outer world as such. Okay. So encapsulation basically means you are wrapping some data and certain behaviors, and you're just revealing what the outside world needs to know to do certain functionalities as such. Okay. Yeah. And I mean, if you look at abstraction, the abstraction is also like similar thing, I would say. Like the natural extension of encapsulation would be abstraction. So you can think of this abstraction as, okay, I have certain properties as such. There are like 1,000 properties in a particular class or in a particular thing, right? Or like 1,000 behaviors or certain like a mix of behaviors and states. And you don't want to reveal everything from the outside, right? What you want to do is you want to just reveal these 5 things, because the outside world just needs to know these 5 things to do certain kind of action or certain kind of like to implement something as such, right? So in general, what you want to do is you would want to have abstraction at certain layers where you only provide access to things which are useful for the outside world. So I would have a lot of complexity inside this class, right? I could have like 1,000 variables, 1,000 functions, and doing like too many things, probably, if that's how we want to do, right? But in general, from outside, you'll probably only reveal like a few of those, like the most 5 ones, right? So you can think of this as whenever you are going to create public functions in a class, you're basically doing is you are revealing something to the outside world, saying that, okay, this class can do these kinds of 5 things. And if you don't want to reveal those like other functionalities out of it, you just want to keep this as private, right? Because probably for doing these things, they don't want to know a lot of other stuff as such, right? Yeah. A real world example, if I want to take, is if you look at your car has a lot of different things. Your car has an engine, has carburetors, has windows, has doors, has a lot of screws and nuts and bolts, right? Do you need to know everything when you're trying to drive a car? Not really, right? What do you actually need? You need to know about steering. You know that, okay, when you steer to the right or steer to the left, the car would move in a certain direction. You need to know about the gear. You need to know about when you plug in the key and start, you can start the car as such, right? So if think of this in real world, if somebody is trying to build this as an like a oops thing, right? What are they actually doing? So what they're doing is like in the real world, they're just revealing a few things, right? They're saying that, okay, these are the 5 functionalities or 10 functionalities which you need to do. You don't need to know about all the other aspects of it, right? So there might be 1,000 screw bolts into the car, in the car, right? But do you want to know all of those 1,000 things as such? No, it's not, right? Yeah. Okay, so like, what do you actually need to know when you're trying to drive a car? You need to steer right, steer left, accelerate, deaccelerate, apply brakes, change gear, change speed, and things like that, right? And if you want to open, close the windows and things like that. So there's a limited set which you want to reveal from outside. But if you look at the complexity which is inside, right, there's a lot of complexity inside which is going on, right? You are basically not trying to reveal everything out, right? If you do that, probably it becomes very difficult, right? So if somebody tells me that in order to start a car, I need to start the engine, like probably get out the hood, do something on the inside the hood, and then come back and do something like this, it's going to be very difficult for somebody to do that, right? So you can think of this as abstraction is also in a way in which you ease out the use or how somebody's going to use it from outside, right? Or how is somebody going to use some certain functionality and certain behaviors. Okay, yeah. Somebody says, can you explain the difference between the two? Yeah, okay. So encapsulation and abstraction, you can think of encapsulation as basically wrapping up this into a single unit, right? So when I have a class car, I'm saying that the whole car thing is one object, or so like one class. And if I want to create an object, it's like this object is of car class, right? So I'm wrapping this into one unit as such, right? The whole properties and states and behaviors are going to get into one unit. In abstraction, what I'm doing is I'm saying that, okay, this is a car, this is one entity. And on this one entity, you are able to do these 5 kind of things as such. Okay, you are able to use this in certain way, and this is how you use it and things like that. Right? Okay, I hope this is clear. So encapsulation, okay, abstraction. Now let's move to inheritance as such, right? So what is inheritance? Inheritance is basically like in real world also, right? Let's take a real world example and probably use the word inheritance as such. If you belong to a family who has like a lot of property in them, right? You inherit those properties as such, right? For example, if your family had a house at some place, once like they go off, or when they probably die, probably that is inherited to you, right? So by default, everything which is there in your family lineage probably comes to you as such, right? So what is happening? You are inheriting that house, or you're inheriting those lands and properties and things like that. Difference between abstract class and concrete class. Okay, yeah, I'll come to that, right? So I think probably during it, like explaining inheritance, I'll also deal with this. Yeah. Okay. So in general, inheritance means that you have certain properties and certain behaviors, and somebody who's inheriting from this would also have like those certain behaviors and things like that. You can override and you can do certain things, but yeah, I mean, in general, inheritance is basically sharing those properties and sharing those behaviors as such. Okay. Why do we use inheritance? We use inheritance to basically, like, I would say, like, you can think of this as an extension of code reusability. So if there's a base class, right? For example, if humans, like I'll take an example of a human class. And in the human class, there is certain property like can speak. And all the humans actually speak in the same language. Let's take an example, like if they speak in the same language, or they can make a noise and things like that, right? I could just say that all the objects which are derived from this would have the same property and they can speak or make noise as such, right? So in that case, what instead of each or like when you're trying to create a new class, instead of like adding the same property of behavior in those classes, what you can say is that I can just inherit from that class. And by default, I get all the behaviors which are there. I get it as a side effect as such. And now I can reuse those side effects if I want to, right? You don't have to go ahead and write the same code as such. So you can think of this as you can keep the behavior at a particular place, and everybody who's inheriting from that has accessibility to that behavior. They can choose to basically expose new things in a child class, I would say. So they can add more functionalities, or they can even override this functionality, right? For example, if you have a class as human and then you have a class as child, the humans can speak basically, but a child can basically not speak. If like think of this as a toddler or somebody who's smaller, they can just make certain noise or certain things like that, right? So you can override the method in the child class, which is child, or in this case, it's also called as child. You can just say that, okay, they can basically make noise. Instead of speaking, they can, like in the speak method, you can just say that they can just make noise or certain things like that. Okay. I just look at this. I don't understand the difference between abstraction and encapsulation. Okay, so because just to say it on the high level, and encapsulation means wrapping up into one unit. So like a class represents certain states and certain behaviors. And this is basically also wrapping up the whole thing, right? The states and behaviors are wrapped into one. So that's encapsulation. Abstraction is basically saying that this class, or this thing which you have wrapped on, how it gets used and what is visible from the outside world as such, right? So that's the difference as such. Okay. Yeah, you're right. Sonali is right. Okay, moving on. So inheritance basically means that you have a particular class which has certain properties and certain behaviors. In the child class, if you want to reuse those things as a natural extension of this, you can basically inherit from that class and have the same properties and behaviors as such. Okay, we're gonna like look into some examples so that we get clearer on this side. But like just for like basic definitions, you can think of this. Right? There are two kinds of relationship normally in OOPS. There's something called as is a relationship. So if you can think of this, if I say a child is a human, then it seems to be a natural fit, right? Because a child is a human. A child is a smaller form or a younger form of a human as such, right? So that is a relationship. And then there's something else which is called as a hazard relationship, and which is composition, which we'll discuss in later as such, right? So you can think of inheritance as a parent-child relationship. So the base class would have certain properties. The child class would inherit those properties. They can also have certain more properties as such. But yeah, that depending on the situation as such. Okay. Yeah. Why do we use inheritance? We use inheritance to basically code reusability. And if you want to do certain like polymorphism, or like certain, if you want to change the properties of the certain behavior at runtime, you also would use inheritance. And we'll see examples about that. Okay. Some basic nomenclature. Class is what a class is. Subclass or child class is somebody who inherits from the base class or the parent class as such. Superclass or parent class is a top level class. And we use this for usability as such. Right? Okay. There are different types of inheritance. There's a single level inheritance, which is a class. In the first diagram, you can see that a class B inherits from class A. The second inheritance level, like type of inheritance, is multi-level inheritance, in which class B inherits from class A, and there's a class C which inherits from class B as such. So you can see that there's a multi-level inheritance as such. Hierarchical inheritance is when two different child classes inherit from the same base class as such. Types of inheritance, more types of inheritance would be multiple inheritance, in which a class C inherits from class A and class B. And just for your sake of knowledge, in Java, we can't do multiple inheritance directly. If you want to do multiple inheritance, you'll have to use interfaces for doing that. Probably I'll keep that outside of like scope for this particular conversation or session. But yeah, you just need to understand. And then there's something called as hybrid, which is a mix of, I would say, hierarchical and multiple inheritance. Okay. Okay, now I'll just take a pause for a bit. I'm gonna show you how to do this in certain code, probably in certain way. But yeah, So now let's take an example, right? So let's take an example of shapes, right? So suppose I have a shape class. This can be an abstract class, or let me write down. So there are three things also which we need to understand. This is called as abstract class, interface, and then normally I would say a class. So we've already dealt with this, so I'm not going to discuss about this. So what is an abstract class as such, right? So and I'm going to take a reference of Java in this case. There might be something, it might be done a bit differently in other programming languages, but that's it. Yes, multiple inheritance using interfaces are, I would say, a different kind of inheritance. Probably I would not call it as real inheritance as such. But yeah, you would be able to accomplish the same behavior as such. If you want the same method with different names, you have to override. Yeah, okay. I'm going to discuss about overloading and overriding also. Just give me a moment, right? So there are two concepts. One is abstract class, and the other is interface. Right? So in general, the difference between abstract class and interface is, interface, you can think of this as just a contract. Like, this would basically telling you like, okay, so anybody who wants to implement this would have this kind of a contract, right? For example, if I just have an interface shape, right? I would have like, I can have things like static constants, right? I could have like public static like things, variables, or I could have public functions as such. So for example, I'll just take an example here, would be like I can have certain things like probably int is not the right return type for this. I could have certain things like a double area. And I just have this method, right? Suppose just for sake of simplicity, I'm just taking an interface which has only one function, right? So if you can think of, if you can look at this, right, what I'm doing is I'm defining a contract saying that there's a interface called a shape, which has a method which is double, which gives you area, and which is like a double type, return type is double as such, right? Now, if anybody who wants to implement this interface, right? So let me take an example. If I have another class, suppose I say square. Now, if I want to do something, probably this is also something which you need to know is when you try to implement or like concrete out, or if you want to create an object of a shape interface, or if you want to implement a class out of this interface, you'd have to use the implements keyword. I would say class square implements shape. And in this, what I will do is, because I have like implemented this, I would have to implement this particular function as well. So I would have like public double area, and then I can have certain behaviors inside this, right? So what have I done in this case? I have defined a contract saying that anybody who wants to implement this particular interface would need to have this. If you don't have this, you will not be able to move ahead from this, right? So interface you can think of this interface, that interface only have contract kind of a behavior. It does not have like any implementation details as such. It just tells you that, okay, this is the contract, and if you want to implement from this, you'll have to follow this contract as such. Okay. Okay. Somebody is saying that, but in child we are writing the code from zero. How are we using parent class, and how am I achieving close usability as such, right? You can think of this, Sashi, that if you have if you have defined certain behavior in a base class, in the child class, even if you don't define that behavior is already there as such. So you have that reusability, right? So if you have defined a function in the base class saying do XYZ with a proper definition of this, you'll be able in the base class, if you call it method, you'll be able to get that property as such. So yeah, in most cases, memory utilization would still be there. You'll have an object of the child class, which you'll have to create like those things, but you can do sharing of those kind of stuff, right? Skip to the good part. Gaurav, sorry, I'm going to try to wrap this up as soon as possible. Because this is probably only syntax is different. Okay, I'm just going to move in fast, I would say. Okay. So you can see this, that interface, you're defining a contract, and you are able to do some implementation out of this, right? So this square class is basically you have implemented a square which is in implementing an interface shape, and you are able to see that there's you will have to override this property or this behavior if you want to implement an interface as such. So interface on a top level is just a contract as such. In abstract class, what you need to do is I'll say once again, the syntax would be abstract class. If I wanted to do the same thing, I could have just done something like this, right? Shape, right? Now I can have I'll have another method. So I'll have the same method called as one thing. I'll have one method called as void display, which is gonna have system.out.println something like display. Suppose if I had certain behavior which was common to all, I could have just put this into this particular function, and assuming that display is a common behavior for all the classes or all the classes which you want to inherit from out of this, right, would have the same behavior. And then you can have another, the same thing, I can keep it, right? So because I'm not really sure of how the area is going to be calculated for the child classes, I would just say double area, and I'll just leave this thing out, right? Or I could say abstract double area method out, right? Now, if you look at this, in abstract classes, what you can do is you can define a contract, and you can have some certain implementation as such, or certain base implementations as such. Now, the same way, if anybody who wants to inherit from the shape class could basically go ahead and override, they will need to override this method, but the properties which are there or the behavior which is already there in the display class can be reused as such. Okay, so the difference between abstract class and interfaces like this is it's basically saying that you have interfaces are just contract. Abstract class can have some certain functions with certain implementation details as such. Why we use the interface when we can have abstraction or abstract classes as such, right? So it depends on the use cases. In certain cases, you just want to define the contract, but because you don't see any similar behavior in any of those particular things, right? For example, if in this case, right, display was just saying display, right? If you wanted to have something generic, if I want each of the classes to have their own display methods, right? For example, you want to tell the class name, or you want to do anything different, right? In those cases, if you don't have anything common, you will probably not want to use an abstract class as such. You can just call it as an interface on the top level. If you know that there's certain behavior which is going to get reused in all the child classes, probably having an implementation on the base class is useful, because you're not going to copy paste that same behavior at all places. But if in cases you're not really sure about how the behavior is going to be, probably you'll have just an interface saying that, okay, this is the contract, and all the child classes would have to basically implement those particular functionalities. If you just want to ask, like, if you meant by what is like, why do we do abstraction as such, or why do we even want to consider having an abstract class or interface, it's just, you can think of this as because we want to do something which is called as runtime polymorphism. So suppose in this case, or in the previous case, I could just say shape A is equal to new square, right? I could just create a new object in this case. Tomorrow, if I have another implementation of like, suppose if I go back and I say that I have another class called as triangle, I could just say that, okay, shape B is equal to new triangle, right? So what it helps us with is, you can see in this case is, you are able to assign the base, I would say, class, or the generalization, basically in this term, the generalization thing, you can assign the reference of the generalization to any of the objects on the right-hand side, right? You're able to do this easily. I cannot do this, right? I could not say square B equal to triangle A, because this is not going to get compiled in any way, right? Because the types don't match each other, right? So what I could do with this is, I could have a base type reference, and I would be able to assign a child class object. And this is going to be useful because at any point of time, if you want to change, if you want to do this at any point in time, I would want to change the behavior, I could just replace this with a different class, right? So I could just say that, okay, shape A is equal to new square. And I could tomorrow say that shape B, I could replace this shape A with like new circle, I would say. You're able to do this without breaking a lot of things as such, right? So in some sense, this is called as runtime polymorphism. So there are two kinds of polymorphism. And the last topic was this polymorphism, which was basically you can change, like, you can change forms when and where required as such, right? Okay, 1 second, I'll just take a pause. No, because it contains abstraction and row stuff. Can you tell me where it is applicable? When abstraction is applicable and not interface, and vice versa. You can think of like any place. 1 second, can you tell me a real life use case where abstraction is applicable and not interface, and vice versa? So I think what you mean is when you would use an abstract class or when you use an interface. So you'll use an interface when you're not sure of how the implementation is going to be. Or you can think of this as, if you know that each of these implementations is going to be different, right? So for example, in this case, if I look at the interface, the area method would have like different implementation depending on what you're implementing it for, right? For example, triangle would have a different area method, circle would have different, and things like that, right? So in this case, I would probably want to use an interface. In certain cases, you know that the behavior is going to be same even in child classes. In that case, probably you would want to use an abstract class and a function. You would implement out the behavior of that function itself. Yeah, so polymorphism is the basic meaning of polymorphism is many forms, and the ability of an object to take different forms depending on what the context is, right? The same thing can behave in different ways depending on what the situation is, right? And there are two ways in which you can get polymorphism. One is called as method overloading. And there's also something called as operator overloading, but because in Java we don't support operator overloading, you can just think of this as like one way in doing it in Java. So if you think there is a method, like suppose I have a method called as void calculate, and it takes in as an integer a, it takes in an integer a and integer b, right? And then we have another method, and it's gonna have some different behaviors in this, and I can have another calculate method, which now works on 3 different integers as such, right? So if you look at this, if I'm trying to write a client, I would, if I say calculate, if I call calculate at any place with two values, 2 and 3, it's basically gonna pick up this function as such, right? But if I gonna call calculate with like 3 objects, or 3 integers, I would say, then it's gonna use this as such. So if you look at this, it is behaving differently. The same method name is behaving differently in different contexts, right? If you look at this, the context changes. In this case, it has 3 integers, so it's gonna pick up this. If it has 2 integers, it's gonna pick up this, right? So this is called as method overloading, in which you have the same method, but with different parameters which you're gonna pass in. And based on this, at compile time, depending on what matches this function, you're gonna have this as thing, right? So you can use that. Okay, the other thing, so if you can think of this, this is happening during the compile time, right? So the compiler, when it's trying to compile the program, would look at this and would be able to bind it to this, saying that, okay, as you're passing in 2 integers, I know that this is the function which is more suitable, or the exact match, or the most common match for this, and I'm going to use this function to do this. And if for example, if I have another method, if I'm trying to call another method with like 4 variables, 2, 3, 3, 4, it's going to fail, saying that, okay, I don't find any right contract for this as such, right? So the behavior is defined during the compile time as such. The other one is called as method overriding. Which is basically runtime polymorphism, in which what happens is, if I have a base class, right? I have a base class. Suppose I have a base class and I have like an area method here defined here. Now I have another child class. I would say A extends base class. Right? And now if I just put it here, like, so suppose I also have like an area method defined over there, right? I could do this, right? I could override this method, saying I can just have a keyword as overrided, right? Now, depending on the runtime, right? What I want to use depends on like the use case there, right? So I could just say, I could just have an object saying that base class A is equal to new base class, right? And I could say that A dot area. In this case, this is what is going to get used, right? If I say base class B is equal to new A, suppose this is a child class as such. Now, if I say A dot, or say B dot area, this is going to call this child class as such, right? So in some way, I'm able to decide, or I'm able to say that, okay, during the runtime, or when you're trying to run this. So once this object is created during the runtime, it's going to find out like what's the right match for this, and then it's going to like implement, or like it's going to call that behavior as such. So this happens during the compile time. Like you're looking at what is the right match and you're doing it. And this happens when the execution is starting working, right? So when you're trying to execute a program, at that point, dynamically, it's going to look at it and just try to find this. This is called why to use overriding instead of creating method in base class. You can think of this as if I wanted to change the behavior, right? So for example, for some case, I have a behavior of area where in this case, I was doing A into B. Like suppose I implemented A into B, but now this particular class is a different class altogether. So suppose if the base class was a rectangle and this is a different class altogether. So probably it's a circle. I mean, for any reason, if you want to change the behavior in the child class, you would want to override this behavior, right? So, and we're going to talk about this in the S.O.L.I.D principles also. So suppose my base class has a function called as speak. If in the child class, for a particular child class, I would say, they can't speak. Then in that class, you would want to override that behavior and say, like, you can throw out a runtime exception, or you can do something like saying that this can't speak as such, right? So you would want to do, if in the child class, if you want to change certain behaviors, you would want to override those methods as such. So what is @ override? So basically, in general, you don't need to do this. I mean, so it just tells you, if you look at this method, right? This signature just tells you that, okay, you are overriding something from the like base class as such. So this is not a new behavior which devising, you are basically saying that, okay, the behavior which is there on the parent class, I want to override this to certain different behavior as such. So this is just an annotation just to tell you that it's an override method as such. In general, if I'm not wrong, I don't think so. Even if you miss this, it's going to be a problem. I think it's going to work and your program is going to compile as such. What's the difference between extends and using? I'm really I think this is in different context. Probably this is not for Java. In Java, you use extends keyword when you're trying to override a class as such, or when you're trying to create a child class from a base class as such. I think using is for some different language. I don't remember exactly what. Probably might be C++ or something else. Yes, exactly. But why are we overriding when we can achieve the same by help of creating method in the base class? Why is this override came? Yeah. So, okay. Let me just put this out, right? So suppose if I have a base class, right, and I have a certain behavior, like I have a certain behavior called as XYZ. One second. Right, I have a certain behavior, and I've defined this behavior. This is a this is like a concrete function as such. Now suppose I have a class A, B, and C, and two of these have the same behavior, but C probably does have a different behavior for XYZ. Right? This can happen, right? There might be other functions and other functionalities which are same for all of this as such. But in this case, if you look at this, I can basically say that, okay, A, B need to, like, you don't need to do anything because they have the same behavior of XYZ. But in this case, you'll probably say @ override, right? Like you want to override the behavior of this XYZ because this does this particular functionality differently, right? So this is the reason you would want to override this. What about Python? In Python, this happens a bit way differently because you'll have to read about like the statically and dynamically typed languages. I think I would say the extension bit and like the inheritance bit remains the same, but I think the interface bits changes a bit. You would still have interfaces, and I mean, I think you still have the interface that they have the abstract class property, or you don't have an interface as such. Not really very sure on the Python bit right now, but I would say like you'll need to look it up. I know that they have abstract classes and they generally extend it from this. I think they don't have interfaces; they just use abstract classes as such. But I might be wrong. I'm not really sure about that. Yeah. So, Akhil, I think their Java now supports variable parameters. Said I think varargs or something like this, in which you say integer ... like you can say this. So it basically means that suppose if I have a function called as, it basically says that you can have one integers, two integers, or more than that, and you can do certain things around this, right? So you probably have to read this up. You have varargs, I think, in Java, in which you can see how you can do this. Okay, I'm gonna move on. Otherwise, it's gonna take more time. I think it's already 12, so I just want to cover the last topic. There's something called as composition, right? Which is a kind of hazard relationship, right? So if you remember correctly, we told that if you have a base class and if you extend out of this, and this is the symbol for extension. Let me draw it better. There's a base class. And just now, if I have, like, I can have child class A and child class B, right? And I could just say that these are basically A is a child class of base class. I can say this, right? In the same way, I can see B is a child of base class, right? So I could say that A is a base class, right? Or A is a type of base class, or B is a type of base class as such, right? So this was inheritance, right? And the other thing which we are talking about is composition. And you can think of this, right? So at any place I have like a class A. In this, I would define something like a private B object of B, right? And if I define this all, and there's a class B as such, right? Which can have certain things. If you look at this behavior, and if I want to draw a UML diagram out of this, this looks like A, B, and A has a B, right? Can I say A has B? Can I say that? A, basically it means that A contains B. Right? So this kind of relationship which you have when you define a behavior in which there's a class which is contained, which contains another class as such. In general, it is called as composition. So you're composing a class A which has the class B as such. And this is how it looks like in a UML diagram. And you can basically say that A has something in B, or A has an object of B as such, right? I'm going to discuss about this later. I mean, more in details later, but you should understand this as such. Yeah, okay. So you can think of this, that when you started off building it, probably you felt that this is going to be a property which is going to be used at every place. And in software world, we know this, right? You are going to get changes as such. So the moment you get changes and you realize that, okay, now there's something which does not match this as well. So you might end up in that situation. If you know this upfront, probably you're not going to end up in this situation, right? But as software is built incrementally, probably you're going to have this scenario in which you started off with something and you thought that this is the right thing to do it, but later on you ended up with doing that. Yeah. Okay. So if you guys have worked on big organizations who have a lot of already existing code as such, right? You can just claim it out there that most of the time which you spend is basically about reading, rereading different codes and trying to make some enhancements to it, right? And on the hindsight, the enhancement doesn't look like really large or really big changes as such, right? There are minor changes which you won't want to do, but the only thing is, in order to do those changes, you'll have to go through a lot of code to understand what needs to be changed and where you need to make the changes as such, right? So in general, there's a rule which says like a 80-20 rule, which says one second. Yeah. In general, we have a 80-20 rule, which says that you are going to spend 20% of the time writing the code and around 80% of the time maintaining the code. So if you're going to spend most of the time maintaining the code, it's better to write a code which has certain properties as such, right? Which is if you look at some proper written code, right? I could just claim that if you have written a code in a particular way, you are able to change it properly. You can change it, you can maintain it. It's not that hard. If you want to make a small change, you don't have to make changes to too many files and things like that, right? Those kinds of change, code is easier for you to maintain as compared to the other side, where if you are you have written a code which is very hard to maintain. Any small change will require probably changes to 10 or 12, 15 files. It's very hard to understand because you're probably jumping around a lot of other files to see how the changes are going to done and things like that, right? So in general, when you're writing code, you should always think about how are you going to maintain it. Have you written the code in a certain way that it is extensible enough? That it tomorrow, if you want to make some changes to it, is it easy to make those changes? Is it too coupled where any small change will require too many changes to these files? You should always think about this as such. You should also think about what is the part of the code which is going to change more often versus what is the part of the code which is going to remain more constant as such. And how do you deal with those things? What happens if you want to change the certain algorithm going forward? If you want to change certain databases in the tomorrow or in the coming future, how do you deal with this and things like that, right? So when you're working on legacy code, you do spend a lot of time in reading those codes and things like that, right? So you should always think about this, that when you're writing a code, you should also have certain good properties, right? It should be maintainable. It should be extensible. It should be maintainable. It should be easy to read. It should not have too much of coupling and things like that, right? So now coming to the design, solid design principles as such, on the top of it, why do you want to use solid design principles, and why do you even care about solid design principles? So I'll just read out a few things, and then probably we can discuss on top of this. It makes the code more maintainable, and it basically means that it's changeable in some form, right? It's not very rigid. Tomorrow, if I want to make some changes to it, I can make it easily, right? I don't have to worry about making change in one part of the system and the other part of the system start falling apart, right? So And like, we have seen this a lot of times, right? We make changes to one piece of code, that piece of code works, and we are able to make it work, but in certain other things starts failing, right? As a side effect. So, I mean, how do you deal with those kinds of things? And this is what S.O.L.I.D principle defines as. Right? It makes it easier to quickly extend the system and add new functionality, right? And somebody comes to you and add more, you should be able to do a lot of to functionality and without cost. Your code should be easier to read and understand, and you should spend less time in figuring out how to do those like changes as such. It should be intuitive enough that anybody who comes to this was able to like, okay, looking at these classes, I understand what is happening in these classes, and I can just go and make changes there, right? Instead of going and catching order for one of his seniors who has written the code and asking him, if I want to make this changes, where do I make those changes, right? So if you have certain, like, if you follow these principles, it makes it a bit easier to do all of these things. Okay, so now we're going to start off with the first principle. Okay, now coming to the S.O.L.I.D principles. The first principle is called as single responsibility principle. Yeah. So this is something which is a bit difficult to comprehend if you look at this in the first stage, but we'll try to break it down into certain like smaller pieces to understand, right? So single responsibility principle, it says that a class should be responsible for one thing. And most of the time, what people think about this is, so do you mean that the class should only have one public function? I mean, if I look at this and if you think through this, probably it seems like it, right? I mean, if I want to actually follow this all, the single responsibility principle, I might end up in a scenario where I have only, like all the classes have only one public method as such. That's not true, I would say. You can think of this in a different form, which is a class should have only one reason to change. And this one reason to change might be very different. It might be that the class does certain things, which is used by a certain owner or a class of owners or a class of users as such. So if they want certain changes, probably you would have to make changes to only this particular thing as such, right? So in certain ways you can think of this is it can vary. The single responsibility, the responsibility part here, or the single responsibility part here might vary depending on what your situation is, right? In general, what you would want to do as a principle is you would want to find out what is changing and why this particular code would change. And you would want to take out everything which is not relevant to this outside into certain other classes or certain other places as such, right? So in this case, what you want to do is I would want to define a class in a certain way that it has only one reason to change. And this reason might be because it is doing something which is used by a certain group of users or certain class of users as such, or like whatever the thing might be, right? But I would want to keep similar things at one place and different things at different place as I would say, right? Like you can just think of this, and this would need some context, I would say, because the reason you would want to keep one thing in one place and one thing in the other place, right, would depend on what situation you're acting on. And we'll see an example which will make it a bit more clear. But yeah, in most of the times, you would have to intuitively think about this, that if I'm going to place this in this class, or if there are three things I want to keep this in this particular class, are these three things relatable? And the relatable aspect can come from, are these three things being used by a same piece of code or a same user or things like that. So in general, single responsibility principle means that you would want to keep all the things or certain things which have certain behaviors, which is similar at a certain place, and the rest of the other things we would want to take out of the class. Why? Because if those different things change, do you want the people who are using this to also change? Can it have a side effect and things like that? Will this recording be shared? Suryadeep, I'll have to check. I think we can do this, and I'll check with the team, and probably we'll be able to share it in some form. Okay. Yeah. Okay. Now let's take an example. Yeah. I'm sorry. This looks horrible, but I hope this accomplishes this, right? So suppose you have an employee class, And there are three functions over here, right? Three functionalities which this employee class does. One is to calculate the pay. The second is to report hours. And the third is to save, which is basically like save to database, I would say, right? So calculate pay is to calculate the pay of the particular person, like of the particular employee, I would say. Report hours is basically to generate the reports of the week or something like this. Report hours in like something ways, and save is to save this particular employee thing to the database as such. You can think of this as it is tied up to certain ORM or like which does the saving part into the database as such. Okay. Now, if you look at this, these three methods which we have, right, looks to be similar. Like we can say that, okay, what's wrong over here, right? All of these three things are basically using employee instance in some class. Can we get this presentation link? Yeah, I'll share this in a bit, right? I'll share on chat. So you can see this, right? There's an employee class which has three methods, and it seems like this whole calculate, pay, report, hours, and save seems to be related to employee as such. So if I just look at this, I'd say like there's nothing wrong with it, right? But now, if we dig deeper, we'll find something, right? So if I go into this, right, and go into more details, in general, you can see this calculate pay can be related to a certain class of user, right? So a CFO might be interested, or a chief finance officer might be interested in the calculate pay function. Why? Because it's related to finance, and probably he or she heads that particular domain as such, right? Report hours might be of use to a chief operating officers because they take care of the human resources and things like that. And whereas the other save is probably something which is like saving to database, and it's more technical, and probably CTO is more interested in this, right? Now, so far, it still seems fine. You don't see any problem as it. But if you move forward from this, if you think about this, right? Suppose we have like somebody or a developer looked at the whole functionality building, like who was building out the same functionality. He felt out that, okay, calculate pay and report hours has certain common thing, which is like a regular hour. And he or she was able to like carve out a function which was used for both of these, which was regular hours, right? I mean, it might happen that at that point of time, the way the regular hours were calculated was same for calculate pay and report hours. So what he did was, he or she, in this, I mean, we're not mentioning it here, but there's a private method, which is basically calculate regular hours as such, right? Now, tomorrow, if for certain reason, the CFO comes and says, or the CEO in this case would say that, okay, we are going to make some changes in the way we are going to calculate the regular hours or calculate the hours, report hours, something like, right? So we would have like regular hours, and we would have some extended hours or something like this, right? So now if you look at this, probably there's certain changes which are being made to this regular hour function itself, right? And as you can see, this is getting used by two functions, right? For some reason, if the change is made to the regular hours or the way you calculate regular hours, now there is another developer. So example, think of this as the developer who made these changes is not a developer who's been asked to make these changes now, or probably from a different team, right? It can be that they are different from different team itself, right? So now as a developer or as a different developer who's working on this code, now comes in, sees these kind of code, he or she feels, okay, I can do this. They go ahead and make changes to the regular hours code. Now what happens? They make the changes. The changes work for the CEO part of things, which is report hours. And the report hours works as expected by the CEO now. So the recent changes, which was expected, is accommodated as such now. But the problem happens at some place else. The CFO now sees that the calculate pay has changed in a certain way. Either increased or decreased, or there's certain side effect which has happened. And if you look at this, because the way this whole thing was set up, there was no way in which the CFO knew about this, right? Because probably the CEO and the CFO don't interact about all of this. And they would be thinking, okay, I want to make changes to certain things of my domain of functionalities, right? I mean, why do I need to inform everybody as such, right? But if you look at it, the problem happened, right? Now the CFO is getting a different like pay for each of these employees. Why? Because there were certain functionalities which were getting used now, which is called a side effect. The side effect is cost in the calculate pay method or the calculate pay functionality, because we're using a regular ask functionality at certain place as such, right? Did you get this whole scenario? This is what can happen if you are building certain things like this, right? So in this kind of setup, these kind of things is common, right? And you'll find this out, right? You and me have always worked on certain things like this, right? Where we're trying to fix something or trying to change something, and we made those changes and we tested those changes. So we are a good developer and we have tested all those changes. But what happens at certain point of time, like after 2 days, we'll get to inform it, okay, there's certain side effect which is happening, which is probably something else is failing as such, right? So these kinds of things can happen. So what would be a better way to deal with this, right? Certain things, in certain ways, we want to deal with this in a better form. You'll probably think of this in certain things, certain way, right? This is basically saying that, okay, these are 3 different classes who have different kinds of functionalities as such, right? So I can basically break this up into 3 different classes called as pay calculator, which is going to calculate pay, hour reporter, which is going to calculate report hours, and employee saver, which is going to save the employee as such. And if you look at this, these 3 all interact with employee data, and there are 3 different functionalities as such, right? Now, if you want to make any of the changes, you will only be making the changes to this particular class, and there are less chances of side effects. If somebody wants to use a util function to do the same regular ask calculation, then you are screwed again. But in general, hoping that if you're going to do this, you're probably going to have a different responsibility and you have a different function doing the calculation, or you probably have a calculate pay in which you have a private function doing the calculation for regular rather than things like that, right? So you can save yourself from doing all those kinds of changes as such, right? Now, if I go ahead, if you look at this, right, now you can say that, okay, I have done this, but the problem is at someplace else, right? Now, people who are using this class happily, because they had only one class to use and do all of those things, now they have to actually understand, like, now they will actually have to use 3 classes, right? Because they would have to, basically, they'll have to create instance for different classes, like pay calculator, R calculator, and employee saver. So there are going to be changes which is going to required on the front end side, right? Or on the other side as such. In some ways, you can avoid this by saying that, okay, from inside, I have different implementations for this, but outside world, the contract, I would want to keep it simple and probably reuse the same contract which I had previously. And you can do is, you can have something like this. So there's a pattern called as facade pattern, which is basically accumulating, like probably providing a contract. You can just think of this as like, it hides the details in some phase, or some form, and provides a contract saying that, okay, this is the employee facade, and everybody who's trying to use the employee object would create an object of this facade, and this can do things like this, right? You can calculate pay, report hours, and save. And you can see that, all of these things. Now, if anybody makes the changes to this, if anybody makes changes to this, right, the pay calculator bit, nothing breaks, right? Because the calculate pay remains, hourly reports remains the same. Like whatever you may want to make a change, you'll only make a change into that thing, and there's less chances of side effects as such, right? So this is a one way in which you can look at single responsibility principle as saying that, I would want to keep things in a class which I know that is very close or tightly bound to it. And I also know that this is going to be used by a certain user or a certain group of users, as well as you can think of this has only one reason to change, right? So I would only change pay calculator class when there's a change in calculate pay as such. Or if I want to change report hours, I will only make changes to the report our report class as such, right? So what I'm doing is I'm creating a single responsibility here. So each class is responsible for doing their part of the job. And even if I make changes to this is not going to have any side effects on the others as such. Okay. If there are different ways in which you could do this, right? If you want to, like, you can also keep this as certain things in this way, right? You're saying that either I could have a facade doing all of this, or I could have an employee class which basically has employee data, which has calculate pay, report hours, and save. And I'm gonna the functionalities, the certain functionalities I would want to keep in this class, and certain functionalities I would want to keep it in different class and such. So you can organize this in different ways as such. And even though I want to make changes into report hours, I'm not going to make changes into this employee class itself. I'm just going to make changes into the report hours class itself. So there are different ways in which you can place them out. But yeah, the basic fundamental remains the same, that a class should do one kind of thing, and it should also, like, it should always have like a one reason. for change. Can we create one interface for regular hours which can use both calculate hours and calculate pay? You can do that, right? But again, the problem would be if you do that, interface for regular, you can do that, right? So you're saying that you would have an interface to calculate regular hours, but basically, if you look at this, you're gonna end up doing the same thing, right? You're end up gonna make like overriding both the methods, or like basically implementing both at two separate places as such. So you can do that. I mean, that nothing stops you from doing that. But I think you're gonna accomplish the same thing, right? So you're basically gonna do is you're gonna have like a pay calculator. In pay calculator, you're gonna implement an interface, and in R reporter also you're gonna implement an interface. Okay. So you are anyways having two different implementations of that case. Yeah. In open close principle, what we say this is, and this is inspired from the modification bit, right? So the reason software is different from hardware is like hardware is rigid and it does not need to change, whereas software is, I would say, flexible and would need to change, right? So all the softwares, I never worked on software which does not require any new feature, functionality, or things like that, right? So you'll start off with a piece and you'll build out something and which will look very different in like a year's time or something like this, right? So we would always want to do some kind of modification or extension and things like that, right? Right. So this principle basically states that you should represent your classes or your structure in such a way that you should, at any point of time when you want to make a change, you should add code to make that change and not modify code in some place to make that change as such. So as far as possible, you should interpret where the change is gonna happen, right? And you should keep that, you should structure it in a certain way that you are gonna add more code to modify, or to accomplish that behavior instead of changing the code in some already existing class as such. And we'll see that for an example. But this means that at any point of time, if you want to make some modification, you should be adding more code or adding more classes or adding more code or modules, I would say, rather than changing the modules which are already existing there. Why? Because obviously we notice that the moment you start changing code, you're going to have side effects. There's something which is going to break. You're going to accomplish something, but it's going to break at some other places, right? Yeah. So you should be easily able to extend the behavior, but you should be able to extend the behavior and not cause side effects or break changes at different points of this. Okay. Now coming back to this, right? So for showing how do you actually accomplish open close principle, let's look into one example. So the situation is somebody is trying to build out an area calculator, or the PM says, okay, we are trying to build out an area calculator. And right now, the area calculator, because I can just look at this and say that, okay, we have a rectangle and we want to calculate the area. So we're just using area calculator to calculate the area for a rectangle. And we said, okay, fine. You are saying this just to build it for a rectangle. I could do this, right? So I'll just create an area calculator class, and I will put this in, say, double area rectangle, and then basically it takes in a lot of rectangles and just calculates the area. Or I would want to display this in a screen. So you can think of this as I'm building a certain UI or a canvas in which there are multiple rectangles, and there's a place where I want to show the area of all the rectangles as such. For some reason, just take it as a hypothetical example. So this is the way you would go it. And to be honest, this is the way I would also do it, right? So I would just go ahead and start writing an area calculator class in which I will just have a double area. And I'll say, okay, pass me all the rectangles. I'll take in all the rectangles and I'll just calculate the area as such, right? And I would do the calculation at this place. So saying, okay, what's wrong here? I can just do the calculation. Okay, I can just have a running sum of area, and I'll do is take in all the rectangles, multiply its height into width, and just get the area done, right? Now what happens, and as we know, softwares do change. What happens is at this point of time, the PM comes back and says, okay, there's something else which we want to do. Like the product manager or the person who's managing this comes back to and say that, okay, I think we did this and we did this well. Now the requirement has changed a bit. Now what we're looking at is, can we do this also for a different shape, or probably for one more shape? I say, can you do it for circles? He or she comes back and says, can you do this for circles? And does not say that we are going to have more extensions to it, right? So we think of this and says, okay, fine, for circles is not a problem. though I will have to make some code change, but I can do this, right? And I'll go ahead and do something like this. I'll create another class called a circle, and I'll do this, and I'll make changes to the already existing area calculator class, right? Think about this. What have we done? We have made changes to the area calculator class, and we've added one more thing. Like instead of passing list of rectangles which we're doing previously, we're passing a list of objects. And what we're trying to do is we're iterating over all the object shapes, checking if this object is of rectangle type or if it is of circle type, and doing some calculations and basically returning the area. If it's a circle, we have a different formula for calculating the area. If for rectangle, if we have a different formula, right? So we have two different formulas and based on the type which we have. But it is to this point, it looks fine, right? I mean, if you look at this, it's okay. And this is what we do, right? But if you look at this, the open close principle says that you should not modify the code. You should extend it or add new classes or new functionalities in that form, right? You should add new classes or new files to do that. But right now what we're doing is we're modifying this, right? Now think of this, that the PM comes back and they say that, okay, add more things. Now we have seen this, it works for rectangle, it works for circle. And what's happening is people are asking for more shapes. They want triangles and they want more shapes and sizes like that, right? So they want more shapes, basically saying. Now you have to build this for all the possible shapes which is possible, or like n number of shapes which is there. So you can see this is a problem, right? One way which you'll do is you'll keep on adding this instead of check. And it's becoming harder and harder for you to read and comprehend, right? So your logic is going into one piece and you'll keep on adding like more code to this. The moment you add one more new type, you'll add more checks like if shape instead of XYZ. You keep on doing this, right? And you see this is going to become a problem. At certain places now, it's becoming harder and harder to read, and probably testing also might become a bit difficult, right? So how can we can agree on this, that this breaks the open close principle as such, right? Now, how can we do this better? We can do this better by doing something like this. Now, instead of having like an area calculator class doing certain things like this, right? What if we divide this into certain things? So what if we have an interface which is shape, which has a double area, and now any of the shapes which you want to implement would implement that from the shape interface and would have an area, because you'll have to override. And this is a place where I missed override. On the left hand side, you will find no override. On the right hand side, you will find override. So I think override is just to tell you that you're overriding something on the base class, but I think the compiler would still work fine. So don't worry about this. I could do this is I would create a class called a circle, which implements shape. And I'm gonna basically override this method with the formula of how do you calculate the circle area, 2 by r or something like this. Pi r square, sorry. 2 by r is the circumference, I guess. Yeah. So in this case, we are going to have a different formula for circle, and the same thing we do for rectangle, because we have different like height and width. We'll have like a different constructor which takes in height and width, and then we have a area method which just is height into width. Right? Now in the area calculator class, if you look at this, we are calculating the shape. We're calculating the area. We just don't need to make any we just pass in a list of shapes, and we do this is for each of the shapes we call the area method or the area function for that particular shape. Right? Now, if you look at this, tomorrow if somebody comes and asks me to do a rectangle, where do I make the change? I add another class called as if the new shape is a triangle, I would add another class called as triangle. I'll implement it from the same base interface, which is the shape interface. And I would basically put in write the area method as such with whatever the formula is, right, for it. And in this area calculator class, right, I don't need to make any change. So if you look at this, in this case, what are we doing to make or modify changes or add new changes? We're adding code to make those changes. We're not modifying anything to make those changes as such, right? So do you think this works better as compared to the previous example? I think it does, right? Because in this case, we are not basically using, or we're not modifying the code as such. But look at this in some form that whenever you add some functionality, you are going to make some changes. It's not possible that at no place you are going to make any change, or you're not going to make any modification as such, right? You are going to make some changes at certain places, right? But at most places, the way you would want to modify this is by adding code and not by changing code as such. You will try to do as far as possible. Is it possible 100%? I would say no. You'll have to make some changes, right? For example, in this case, if you're adding more shapes, there would be a place where you would have to instantiate those shapes as such. It might be different places. I'm not really sure. There would be some client who would be doing new of triangle or new of rectangle or new of circle as such, right? So you would add some kind of code. That, I mean, you cannot get away from that anyways, right? But what we're trying to do is we're trying to keep the logic at certain places where you would want to add more code to make those changes rather than like modify it as such. Okay, so this is about the open close principle. And okay, if you want to take a real world example, like, think of this, and this is something which we tend to do at certain places. So today, if I am working on some database layer and I have a table called as employee, suppose if I have a table called as employee, which does like three things: fetch an employee based on ID, fetch like certain details of the employees and things like that. Today, if I have an interface defined for this, saying that, okay, if my DB is SQL, or if my DB is MySQL, and if I call these methods, right? So my interface says, okay, database employee ORM or employee something, and I would say that I don't care if it's like I'm not defining whether it's using MySQL database or Oracle database. What I'm defining is the interface saying that, okay, there is a function from which you can get employee by ID, and there's a function which you can get employee details by ID, or like more like employee, I would say pay or something like this for a particular month and things like that, right? So you have an interface defined for certain things like that. Now what happens is today, suppose you're using a MySQL database. So the MySQL database, you have implemented certain saying that, okay, connect to this MySQL database or certain things which you have done. And then you say that, okay, for this particular function call, I am going to have a query like this in MySQL, right? You're doing something like this. And your system works as it is. Tomorrow, somebody else comes in and says, okay, now we're moving away from MySQL because we have hit a constraint, or somebody is like, okay, now we cannot use MySQL for XYZ reasons. Now we want to use a MongoDB to do this, right? Now what you can see is the interface from the outside is the same, right? Because everybody's using this interface to understand, like call these functions. Nobody's using it directly, right? Now what you can do is you can create another class called as get employee details from Mongo, get employee by MongoDB or from MongoDB and certain things like that. And if you override all these methods as such, now the only thing which you need to do is that the place where you're instantiating and saying that, okay, use MongoDB or use MySQL as before, you would say that, okay, use my MongoDB as such. Now, after that, everything remains the same, right? So you're able to modify something. You're able to move from one database to the other database without adding more changes as such, right? You're just using, I mean, if you look at this, you're modifying a lot of stuff, but how did you make those changes? You added a new class to make those changes. There might be a few places where you will have to inject the thing like, okay, instead of using this database, use this database or use this class and things like that, right? But if you look at this on a top level, what you're doing is you are you're extending it rather than modifying. And that's what open close principle is. Okay. So Liskop substitution principle, this is the L in the S.O.L.I.D principle as such. What it basically says that in the scenarios where you have certain behavior of a base class and a child class, or you have a certain parent-child relationship as such, any derived class should be able to substitute its parent class without consumer knowing this. So basically, it means that at any place where you are using a child class, you can substitute it with a base, like a parent class as such, right? Okay. The second thing is that every class that implements an interface must be able to substitute any reference to the code that implements the same interface. The other thing is, at any place where you're using an interface, you should be able to substitute anything which represents that interface, right? For example, I have an interface I, which is implemented by A and B. So today, if I say, like IA is equal to new A or something like this, I would be able to tomorrow change it to B because these two are from the same interface as such. Okay, Sashi, I would, okay, like let me use this. Let me go through this. Probably I'll try to explain this example. every part of Get should expected result no matter what the instance of a class you send to it, given it implements the same interface as such, right? So I'm going to explain all of these three using some particular code or some particular example as such. Once again. So what we can say this is, if I have an interface I, suppose I have an interface I, and I have a method A defined over here, right? Now, if I say class XYZ implements I, okay? And then basically I have a method defined with certain behavior, and I have a class ABC, which also implements the same interface. And it also has like behavior A defined, right? So if now I'm just use this, like if I have at any place I have a client, right? I could say something like this. If I want to create an object, I could just say IA, or let's use not use A because we use A. Let's say II is equal to new XYZ. Can you say this? We can, right? So the Liskov substitution principle says that if you have at any place you have a reference of or you have a base reference of an interface, you should be able to like swap it out or interchange it with any reference which has the same implementation. For example, in this case, we have new XYZ as such, which implements the interface I. I also have like ABC as such. So I should be able to do this. Yeah. It basically means that both of this are substitutable, right? It means that I could like substitute from this to this without any side effects as such. And I could do this, right? So if I have called I.A, which is like this particular method, I could just do this here also, right? Like if I change this, suppose instead of this, look, suppose this is, one second, let me just remove this. Like, suppose if I had only this, I had this call, right? Now if I replace XYZ with ABC and run the program, it should work as it is. It should not have any side effects as such. Because if you look at this, this has the same thing, right? These are substitutable. Basically object of ABC type or object of XYZ types are substitutable to the type I as such, interface I as such, right? So this is what it means without having any side effects. So when I call I.A, I mean, it should not have any side effects as such. It should work as it is, as implemented as such. There should not be any changes for which the client is not expecting it, right? Because the contract is for the client saying that, okay, I can use interface contract, which says that I would always have like a public method A, which I can use. So no matter what the object is, I will try to use that, right? So that's what the contract is. Okay. Is it same as factory design pattern? Yeah. Yeah, so I will come to this, Arun. Is it same as factory design pattern? Once again, let me recall factory design pattern as such. Basically, factory principle says, factory design pattern says that you basically need to create different kinds of objects, and how do you create it as such. So I would say OCP is like factory design pattern. Yeah, I mean, let me just think through how would you say, right? Like I would say like it's a bit different in that sense. The substitution principle basically says what is substitutable, right? Can you replace this with this? If these two are of the same type, they should be replaceable. That is what it means as such. Factory design pattern is more concerned about how do you create objects. Do you really care about creating, like, does it talk about substitution? I don't think so. So I would say that pattern is a bit different. The other thing is, I would say OCP is a factory design pattern. Okay, let me again try to comprehend this. Open close principle says that you should modify, you should I don't think so, right? I mean, factory design pattern has a different purpose altogether. The intent for the factory design pattern is that you would be able to create new objects in a certain way without, like, yeah, I would say, yeah, probably like open close principle, you would be able to say that like factory design pattern is one of the implementation for open close principle, because there you say that if you want to create an object of a new type, you basically make changes at a certain level where it, I mean, you don't have to make the code changes as such, right? You can say that. I would say there might be one implementation of factory design pattern which would basically comply with the open close principle as such. Yes, yeah. So Raki, you're right. If you substitute a new XYZ and ABC, it basically is kind of a polymorphism, right? And this is where we'll move forward to, right? Like when we talk about the dependency injection and things like that, we'll be talking about like does it support polymorphism and things like that, right? So when you want to do runtime polymorphism, and if you want to like make it substitutable, right? If something is substitutable properly, it's probably easy for the client to do any kind of operations as such, right? So let's take an example, right? Let's try to break this list of substitution principle. Even though from the outside it feels like the substitution principle is working, but where is it not working as such, right? So let's take this example. I have this in this XYZ, I would say that implement A, and in the same I have like overridden this A function, and in the same thing I have in ABC also I have overridden this ABC function, right? Now, if I do something like this, because for some reason I get to know that this A functionality is not applicable for XYZ class. If I say return new runtime error, runtime exception, I think runtime exception in Java. If I do something like this now, I mean, is it like still substitutable? Is it following the list of substitution principle? Not really, right? Because if you look at this, now what happens if at this place, if I'm going to call this, if I have an object of XYZ, this is going to break, right? This is going to give me a runtime exception, right? So is it substitutable? On the hindsight, it's following the contract of the interface, but is it like following this list of substitution principle? It's not, right? Because it's having a side effect. It does have the same interface, and it looks from outside, it's able to like look like the same thing, but it's not following the substitution principle, saying that if I substitute like from XYZ to ABC, everything else should work as it is, right? But in this case, it does not. It will break, right? Because it will start returning you a runtime exception as such. And if you go, if you look into like, if you go deep into this, a lot of times you solve this by having like a strategy pattern or things like that. You would solve these kinds of side effects by doing this. But if you look at it from outside, it looks the same, right? You say that, okay, if I look from outside, I can see that, okay, this is also implementing A, this is also implementing A. So I see that there's a behavior A in both of these. But when we call that behavior A, it has a side effect. It means that it is not substitutable as such. Okay, is it clear? Let's take an example. Okay, let me just say a few words out of this, which will help you to understand or keep it in mind when you're trying to do this, right? So you can basically say that it's this rule is basically, or this principle is basically an extension of the open close principle as such. You can say that, right? It's saying that in that place we are talking about, okay, so modifying code, if you want to add more functionality, you'd want to basically add more code, right? So that's an extension of this. On top of this, you're saying that when you're adding more code to it, you should not do less than what it was doing before. So basically it says that at any point of time, you should not do less than what you're doing at the base class. So in this case, when I return this runtime exception, it basically means that it's doing less than the base class, right? If for some reason, if I don't have if my signature does not have an exception, right? If I'm having an exception here saying that, okay, it can raise an exception, then probably this would be fine. Saying that at every places you would be expecting an exception at some place. Saying that, okay, if I implement this, you might get an exception, right? That's in the contract itself. If it is not in the contract, and if you're trying to do this, it basically means you're doing less, right? Your behavior is less than what was expected. You're doing less thing in the child class than what should be done in the base class, right? So if the base class has a if the base class says that you do some certain functionality A, you should do that functionality A in the child class itself, right? Another way to think of this is Imagine a derived class throwing an exception that a superclass does not. Right? So it means that you are having certain kind of side effects, right? How list of substitution principle helps better code. Yeah, Sashi, if you can think of this, right? And I'm writing this client, right? If I'm writing this client out, and if you look at this, if I had properly implemented list of substitution principle, right? I would not have this problem, right? My client is very clean and the client will not break at all, right? I could just safely say that I could use this. I could use this A.I implementation directly, right? Without worrying about if there are going to be any side effects or if there are going to be any problems as such. I could do this correctly, right? The moment I do something like this, now if I do this, my program breaks, right? My program breaks as such, right? But if you look at this, the client is saying that I'm not doing anything wrong, but I'm getting a bad result. I'm getting an unexpected result, right? So if you always follow this list of substitution principle, the chances that it's going to work well. Okay, let's take an example. If you're writing a client, suppose we have 5 different, there's a canvas, and in a canvas, you can do, like, there are different shapes, and there's a different functionalities which you do on the canvas itself. And you drag and drop certain things to do some functionalities. If you're able, if everything is list of, like, if everything is substitutable, sorry, it's a tongue twister. If it's a substitutable thing, no matter what shape you're dropping, you're getting the same kind of result, or it works for all the shapes as such, or the functionality works for all the shapes. But if for some reason circle does not follow that same contract, or it is an exception, right? Now you'll find that on the UI, you get an error when you try to drop a circle as such. So do you understand this point, right? We're saying that if you're trying to define a contract, that contract should be implemented in a proper way. It should not just be that just overriding that particular function or that functionality, but you're not doing anything good to it, right? Or you're injecting a side to it. You're saying that you have a contract and you abide by that contract in a proper way, and that proper way is what helps the client to do those things seamlessly. Otherwise, the client will again have to write this code like this, right? If I is an instance of class XYZ, then don't call this, or do something else, or give some certain different prompt, or give a certain UI element, different UI element, right? Is this clear? Yes. Okay. Now, let us take an example, and this is, I'm just going to talk about a real world example where people would be able to, like, relate to it, right? So just give me a moment. I'll switch to a presentation. Yeah. And this is one of the famous examples, right? So user is a client in this case. Don't worry about it. Probably just leave it out for a moment. If you think about this, we have a rectangle class. And somehow, and because this is a long-going debate, right? Is square a rectangle? Right? So if you look at this property, which basically means that square is a rectangle, right? In this case, we are overriding it, or we're saying that rectangle is the base class and this is child class. And we can do this, right? And suppose in this case, if we have, like, if we're doing certain kind of functionality, right? Which we say that, okay, there's a way in which you can set height and set width in the rectangle class. And in the child class, you basically, you have the functionality, right? So set height and set width. But what you do right now is saying that, okay, if I look at it, but in rectangle, there's a height and width to it. In a square, there's no height and width to it. But I could do something like this, that, okay, when you set the height, I will also set the width. And when you set the width, I'll also set the height, right? Because it's the same for square as such, right? Now, if you try to do that, right, what happens is you will get different expectations, right? Your area will change. You'll just set an height and you'll expect that you set a height as 2. Now, if you calculate the area at that point of time for the square is 4, or I would say A into B, yeah, it's square, right? 4. If you set the height as 2, the area is 4. If you set the width as 10, now the area is 100. But what was it expecting at some place? It was expecting 2 into 10, right? 20 to be the case, if it's a proper rectangle as such. So we do see a side effect, right? That the area does not, it's some place, if you talk in mathematical terms or if in general terms, it feels like a square is a rectangle. But if we do this according to list of substitution principle, it is not, because you're going to have side effects. You're going to get a different area and then expected as such, right? And one way to look at this is like the height and width is basically going to inject certain different behaviors. Or if you look at this, one way to do this would be you'll probably override height and width, and you would say that, okay, these are not implementable in this case. Or you would raise an exception saying that we don't support height and width implementation in this particular square class as such. It has a different way to modify its property. It's like a set height, not a set height and set width. In that case, probably we can say that square is not a substitutable rectangle as such. Does this make sense? Okay. Moving on to another. So this was a bad example in which probably this is not substitutable. In the other example, or in the example where it works properly, we can take this example as such, right? So suppose there's a scenario in which there's a billing scenario in which we talk to an interface. This interface has calculate fees, and it has two child class implementations. One is personal licenses. Billing has license, which is a license to an interface, and there are two kinds of interfaces, two kinds of child classes which you have, which is personal license and business license, and both of them implement the calculate fees as such, right? In business license, we can see that it would be like a number of users, right? There might be more than one user as such. In personal license, you will have only person, so it's for one single person as such, right? In both these cases, if you've implemented it properly, and if you call that calculate fees method, it's going to work fine. It's going to be substitutable. Today, if I'm using it for an object of personal license, I'll be able to use it for an object of business license as such, without having any kind of side effects. So this seems to be a good example as such. Yeah. So the next is interface segregation principle, right? So this is the I for the solid. Segregation means breaking, right? So in general terms, you can think of this as if you have a very big interface, like a very broad interface, which does 20 different things. A client would want to use only one of these things, right? Not all the 20 functionalities. And for some reason, we would basically be saying that, okay, if you want to do this, you have to forcefully do all of those things. We should avoid doing that. And in general terms, we'll probably go ahead and look at an example, but in general terms, we'll just read this out to understand this, right? A client should never be forced to depend on methods it does not use. So if there are 10 methods and the client is only trying to use one of them, it should basically be using a different interface rather than using that same interface, right? It should not be forced to depend on methods it does not use, right? Or a client should never be dependent on anything more than in methods it's calling. So if I'm only interested in one method, I should be implementing from an interface which has only that method. It should not have more than what I require or I want to use as such. Changing one method in one class should not affect, if I'm not using one of the methods which is getting changed, there should not be any effect to my thing, right? Yeah. So basically think of this, right? If I'm interested in method A, but there are method B, C, D, E, F in that particular class or interface or whatever I'm using, right? If there's change in A, then okay, fine, I need to recompile and I need to redo all of those things. But if the change is on B, C, D, E, F, which I'm not using, right? I should not be, I don't want to recompile my stuff, right? So it should not affect me in that sense, right? And the last, then the easiest way to think of this is you can replace fat interfaces with small specific interfaces as such. So instead of having too many interfaces or too many things defined, instead of having very broad interfaces which does a lot of things, you can think of smaller interfaces which does a specific set of those things or a subset of those things, I would say. Okay, we will try to come with an example. An example would be this, right? Though I could do all of these functionalities as such, but at any point of time, I will use only the one which I want to, not all of these, or I don't want to force myself into doing all of this. Right? Now let's take an example. If the example here is, so there is an operations class, I would say, which has 3 operations. operation 1, operation 2, operation 3. And there are 3 users as such who use that particular class. But user 1 only uses operation 1, user 2 only uses operation 2, and user 3 only uses operations. If I have a setup like this right now, right, the moment I make changes to operation 2, I would have to recompile user 1 also, right? Because it's using that particular class. So it will have to recompile on its own, right? You'll have to recompile that user class to use the new implementation of the operations class or the OPS class as such. The same way, if the operation 1 has changed, I'll still have to recompile user 2, right? Because this is changing in that sense, right? So in this, if you look at this, what is happening is this is like a really broad interface, right? My interface to use this is very broad. And the side effect is that even though I'm using certain thing, even if it is not changing, if other things are changing, I would have to basically recompile or do certain things like that, right? So it might happen that the recompile might cause some side effects as well as, right? So this should generally not be the case, right? So how can you deal with this? If you can do something things like this, right? If I break this operations class into certain 3 kind of interfaces, right? Whereas there's U1 OPS interface, which has operation 1. There's U2 OPS, which has operation 2. And there's U3 OPS, which is operation 3. If I'm able to break this, and now what I'm doing is I'm saying OPS implements U10 OPS or U1 OPS, U2 OPS, and U3 OPS. If I'm implementing, like, you can think of this as multi-inheritance or multi-level, multiple inheritance, I would say. You think of this, right? If I'm able to do this, and now if the user 1 uses the interface of like U1 OPS, in this case, what happens is, even though at certain point, I'm making change to OPS for changing the functionality of OP2, user 1 does not get affected, right? Because what user 1 concentrates on is saying that user 1 would do something like OP1, right? It will only use, it is only dependent on U1 OPS class and user 1 is only dependent on U1 OPS like code dependency. If I want to talk about this, you would say that user is dependent on U1 OPS and OP1 as a method, right? It is not dependent on anything. It is not directly dependent on OPS. So if we make any changes to OPS, it does not make it, like, it does not matter to it, right? It will not recompile or do any kind of things like that, right? So there's not going to be a lot of side effects in this case. Do you guys get my point? So in general, if you want to understand about the interface segregation principle, it says that if the client is using any certain functionalities from a certain class, look at that class. If that class is doing too many things, which the client doesn't require, probably you need to add certain interfaces on top of this, which says that, okay, I'm going to limit this, saying that, okay, the changes which are going to happen to this, like, only if changes happen to this particular interface or this particular method is going to impact this particular client. Otherwise, nothing gets impacted as much. So we can shield a lot of those things out. Does this make sense? So think of this in a, like, let's go back and like revisit this as a scenario, right? So in this case, what was happening is, even if you make any of the changes to any of the functionalities, all of the user 1, user 2, user 3, which are the clients here, will get recompiled, right? In this case, because we are doing a level of indirection, right? We're saying that it's not directly dependent on this. We have an interface, and then the interface depends on this. We don't recompile unless there's something required, right? So what we're saying is we are segregating interfaces into smaller interfaces and making those clients depend on those interfaces which they only use. Can we make difference with LSP and ISP, please? Okay. So LSP is basically about substitution, right? Saying that what you can substitute, what you can't substitute as such. And whenever you even think of this as, whenever you're trying to build some form of inheritance or you want to do some kind of inheritance, you need to be careful about that, right? It says that only do inheritance when you're sure of that it's gonna work in a certain way and it's gonna always follow this particular path, or it's gonna behave in a certain way as such. There's not gonna be any exceptions to that case, right? So LSP basically talks about that substitutability, saying that is this particular thing, is this replaceable by this thing? Is it substitutable by this particular thing? And not in generally in this terms that you are implementing certain methods or certain behaviors, but also in like when you run this out, will it have any side effects, or is it actually this thing? So you can think of this as it gives you a like you have inheritance, but people use inheritance in a certain ways, right? They would say that I will override a lot of properties in the base class, which is okay, but you cannot override some certain property to not do certain kind of things in the child class, right? That's what list cost substitution principle talks about. In interface segregation principle, it's different. What we're saying is like we look at the dependencies, and you can think of this as in terms of dependency management as such. I want to be dependent on those things which I am really concerned about. I don't want to depend on 10 different things, or I don't want to depend on something which is changeable in 10 different ways, even though I use only one way. If the thing which I'm using is getting changed, probably I need to recompile or I need to make those changes, right? But if I'm only interested in this one thing, but I need to change with because the rest of the 9 things can change. It's not a good dependency to have, right? So that's the difference, I would say, in simple terms about LSP and ISV as such. Yeah. So now coming to the last piece, which is dependency inversion principle. But before coming to dependency inversion principle, let's talk about dependency injection as such. Right. So if you work with certain modern frameworks, I would say probably with certain things with like Spring framework and things like that, you would have always heard the term dependency injection, right? What is dependency injection as a thing, right? Let's look at certain examples. Okay, can you guys see my screen? I think yes, you can. Okay, that is fine. Okay. Now think of this, right? There's a term which is called and which is popular as like prefer composition. Sorry. Over inheritance. Right. What happens is generally it's talked about is that when you do inheritance, you tend to get like binded or like coupled with certain behaviors, I would say as such. Now, because you are using inheritance, you will have to do certain kind of things as such. Whereas composition, it's more flexible as such. For example, think of this. If tomorrow, let's take an example. If I have and I'm using a very generic example as such. Today I have a duck class, which can walk, and which has another method called as display as such, right? Right. Now I know that most ducks would walk, right? So I could say a duck, like there's certain ducks which will basically work well within this particular difference, right? Which works well. So we can say that duck A and duck B is like they both can inherit from the duck class and can do the certain behavior, right? Tomorrow, if I have a different duck, right? For example, there's a C duck, which cannot basically quack, or which can quack in a different way. What we'll do is we'll override this, saying that okay, we'll override the quack functionality, saying that okay, the quack behavior is different and things like that, right? Now there can be another duck which will do like a D duck, which would have another kind of quack. Just take for example, like probably it makes a different kind of noise, things like that, right? Now, if we go ahead and say like, okay, now we figure out that duck can also fly, right? But A and B duck is fine. Like they have the normal fly behavior as such, but C duck cannot fly. So I would say no fly in this case. So I would say this is no fly. And D duck can also do like no fly as such, right? And there can be another E duck, which does fly, but the fly behavior is a bit different. And you can say that it does hop. It hops, right? Fly may, you can just say like this is a hop behavior, like or a hop, it can just hop as such. Right? Now, if you look at this, because I'm using inheritance as such, if I want to, so like in this case, there's no fly and this is also no fly, right? But was I able to reuse that functionality? I was not able to reuse that functionality, right? because I would have to override those things in a particular class itself. I'm not able to override this particular behavior, or sorry, I'm not able to use this behavior. So I could, if I draw a diagram, okay, let me draw a diagram. This is a base class, or I would say, like, let's call this as duck for the time being. Sorry. This is duck, and this is A, B, and assuming these are ducks. Like now, if I want to go, like if it has like more levels, right? Suppose if there were certain things like this, right? This is C and D. Suppose they also inherit, like there's C inheriting from A and B, D inheriting from B, and things like this, right? I could share behavior from this to this, right? I could share this behavior. I could share behavior from top to down, right? The arrow works like this. But what happens if I have certain behavior which is here and here? Because I have to, like, suppose this is, let's say, suppose if I have E and it is also has F. So I'm also taking the constraint that I cannot define this behavior on the base class because it's different for A and B and certain things like that. So I'm not able to do this, right? And like E and F. So if you then think, like, if there's some behavior, right? For example, this fly behavior is same for these two, but not same from the base one, right? Am I able to share it? No, right? I'm not. I cannot share like behaviors among these, right? I would not be able to do that. I would have to basically copy paste that same behavior. The same thing happens over here, right? Even C and D. If you look at this, if like at the same levels have certain behaviors which are same, I would not be able to reuse as such, right? So if we initially like while talking about inheritance, we said that we want to use inheritance because we want to have code reusability, basically sharing of some behavior. But are we able to do that? We're able to do that when it's top to bottom, but not when it's from side to side, right? When it's from this to this, you cannot do certain things like this. Is it clear? Does this make sense? If you look at the previous example, right? This no fly is in this particular place and this particular place, right? I'm not able to reuse both of these as such. I'm not able to share this behavior, right? So inheritance locks you into certain kind of situations, right? How you can overcome this with composition? Think of this, that instead of doing this kind of stuff, if we had like an interface defined. So suppose, or let me think of like, let me not worry about it, just say that this is a duck class. And instead of defining like having methods for those behaviors, if I had interface call as I fly behavior and I quack behavior. Hey, if I have these, like a duck can have, like, so there's a class duck which can have all of this. I fly behavior. And or this is an abstract class, or I can define this as an interface itself. I don't care about it right now. Right? I have a I fly behavior and I have a I quack behavior, which is basically saying that I have an interface. Let me write it down properly. I'm saying that I have an interface, which is I fly behavior. And I have another interface, which has a, sorry, I quack behavior. Right? I define both of this. Inside this, I can do this, right? I would say there's a fly method over here, and there's a quack method over here, right? I have defined this as such, right? Now I'm saying that a duck can have a, like, it basically has a fly behavior and has a I quack behavior. So if I want to draw a UML diagram for this, I could just say this, like, right? I'll just click duck has, so I will say I fly behavior and I quack behavior. Can I do something like this? Can I show the arrays in this form, saying that I has this and this has this, right? If I want to do a UML diagram, it will look like this, right? Now, if I do something like this, what happens if I want to have a new duck? So suppose I have an A duck, right? I mean, I could have like a I fly behavior and I cock behavior. I'm just going to leave out those stuff. The way I'm going to define this is I'm going to pass in the behaviors to it, right? I fly behavior and I cock behavior. This is my constructor for this. And at a certain place where I have a method called as fly, what I do is I would just call I fly behavior.fly, something like this. Or if I say fly behavior.fly. And for same thing for the quark, I can also define the quark in the same form, where I say quark behavior.fly. Sorry, quark behavior.clock, right? I can define a class something like this, right? The moment I do this, right, you can think of this. Today, I said that a duck or duck A can have like a fly behavior, which does like a certain thing, right? So it flies properly. Or I could, let me draw this out. I say I fly is my base one, so base interface. And then there's like a hop fly behavior. Okay, I should show it properly. I'll say no fly. And say simple fly. All of these three are basically like implement the same interface of like a fly behavior. Right? Now I can say this, that while creating this ADUC, I could basically inject a behavior saying that, okay, right now I want it to not fly. So I can just pass in as a no fly behavior, which is basically this fly behavior, right? No fly behavior. The same thing I can do with Quark if I have like different implementations of Quark, like make a normal noise, make a hop or name noise, or some like a different noise itself, right? I could have different things. So if you look at this now, what I'm doing is I'm able to have a very flexible ADUC behavior, ADUC class, which I can inject some behaviors into it. So it's not a very restrictive thing, right? This was very restrictive. If I look at this, if I wanted to do something like this, right? This was very restrictive at, right? It could do only certain kind of behaviors, or it could do certain things which we have already overridden into this space. But in this case, I'm able to inject this at some time later, right? While creating the object, I could define what kind of behavior do I want for this. Do you get the point, right? So this is what a dependency injection is. Dependency injection basically means that at the time of creating an object, if you're able to inject whatever is needed to create an object, right? Or if you're able to pass in things which are able to create an object, you can create, basically, you can use a runtime polymorphism. I would say that it could just be called as a runtime polymorphism, which I'm doing here, right? So I could change the behavior on the fly if I want to. In this case, while creating an object, if I have a setter at some place, I could do it later also, right? So I could have a set fly behavior later. And if a running object, if an object is already there, I want to change the fly behavior for it, I could do that, right? So it's that the behaviors, you're able to inject something from outside, and based on that injection which you've done, it will behave in a certain way, right? So if you look at this, and this is what I said, right? Composition, prefer composition over inheritance. And this is the reason, right? While you're doing the composition, you are more flexible for changes. You can change certain behaviors after this, right? Whereas in inheritance, if you have like built out something, if you've already done something, it can only work in those things. You're not, it's not that flexible as such. It's very tied up or like restrictive in that form. Is this clear? Okay, right. So this is what dependency injection means, right? So certain, like if in certain properties you want to change it, or you don't know how many it is, right? So also one more thing, think of this, right? If there are like 10 different fly behaviors and 10 different quark behaviors, if you want to do it through inheritance, probably you can have a combination, like think of the combinations which it can have, right? Like too many, right? You would have a class explosion as such, like too many classes which you will have. But the other way in which you do a composition, which I'm able to pass in on the fly, whatever behavior, or I can inject the behaviors on demand as such, right? there is less number of classes which I would have, right? I could just use the client to do that. I could say that client, okay, inject this behavior in this particular object, inject this walk behavior, this fly behavior, as and when I want, right? And I could even change it on the fly using setters and certain things, right? So this is more flexible in that regards. Okay, is this more clear? Do you understand why we would prefer composition over inheritance? Okay, now coming back to dependency injection, I think you understand what dependency injection is. There are different ways in which you can do dependency injection. One is through constructors, which is like basically passing in constructors, like in the constructor itself, the example which I showed, right? In which this is basically like you're using a constructor to basically inject a dependency. The other one is using a setter. So in this case, I could have like a set fly behavior method. And I could basically use that to inject, like I would say, iFly behavior, this thing which I'm passing in, right? So I'm at any point of time, if I want to like inject some certain behaviors, I'll be able to do that, right? So I can use this as a setter as well. Okay. The other way is basically using interface injections, which is basically saying that you use, like the client itself uses the interface to inject whatever behavior they want at when they're trying to run that particular object itself. So the client will pass in the interface of the like whatever behavior you want to do. You can think of this like these are the most two common ones which you use. One is a constructor injection, and the other is called as the setter injection, in which you basically pass in the properties or the behavior which you want to use. Is this clear? Do you understand what dependency injection is? And you can think of this as like I'm not dependent on the object which I'm like the creation of the object is independent of like what things it depends on, right? I could pass in the dependencies while creating the object itself, or I could pass in later. It depends on like you're using setter or constructor as such, right? And this gives us a lot of different configuration wala thing also, right? So tomorrow, if I want to like think of places where there are too many things which you can change. So suppose there are 10 different properties which the class uses, and you want it to be more flexible as such. In those cases, right, passing all the dependency or configurations as a part of dependency injection is the better choice, right? And you can also think of this as I could change the behavior on the fly without changing any code by passing different behavior, right? So today, my duck does not fly. A duck flies. Tomorrow, if I want to create a duck which does not fly, I would just pass in the behavior saying that no fly is the behavior now. And it just works as it is, right? Yeah. Okay. So now, what is dependency inversion principle as such? So basically, this principle states that whenever you're depending on something, you want to depend on something which is a general thing and not a concrete thing. And abstractions, I know the word abstraction is used in a different context in different places, so it gets very confusing. But think of this. I want to use something general. For example, an interface or an abstract class instead of a child class. Why? Because tomorrow, if I want to change certain behavior, right? If I'm using a concrete class, I'm tied to it, right? I cannot change it too much, right? But if I'm saying that I'm depending on something which is an interface or an abstract class, tomorrow I could just pass in a different thing to it, right? For example, in the example which you picked up earlier, right? Instead of saying like I'm using no fly behavior as a part of the ADA class or other class, what I was doing was I was using a reference for iFly behavior, saying that I'm using an abstraction or a generalization rather than a concretion. And this helped me that while trying to create an object, I could just dependency inject into whatever I want to, right? The same thing goes with like the constructor which I had. The constructor had like iFly behavior as a parameter and not some concrete like a no fly behavior. Why? Because I want to be flexible. Tomorrow, if I want to, like, if I get a new behavior or if I get a new property or new something else, right? I could just create another, like I could inherit from the iFly behavior interface, and I could dependency inject this into it, right? So did you get the point, right? Like why you should depend on inversions, why you should depend on abstractions rather than concretions as such. Yes, Chetan, I'll look into this. Probably we'll be able to do something. I will be able to like give you some examples on this. Right? But think of this, right? I mean, think of this in more general concepts rather than anything particular as such, right? So today, if I just take an example, right, and going back to the DB example which we had previously, if instead of defining an interface for a database, if I have an interface database saying that, okay, in the employed ORM or whatever model, whatever you want to call it, right? If I had used that interface of a very generalistic thing, I am able to change the implementation then and there and what I want, right? So tomorrow I'm injecting a dependency saying that, okay, this is I'm using MySQL, so I'm injecting a MySQL kind of a DB to it, right? Tomorrow, if I want to change to something else, I could just say that it use MongoDB as a DB cell, and I'm not binded to it. But if I have a hard code, not hard code, if I'm depending on something concrete, right? For example, if I'm not passing like a generalistic thing, but I'm passing something concrete, right? For example, I'm saying that I'm creating an instance of MySQL and I'm passing MySQL to it, not using that abstraction, but MySQL to it. Now I'm bound to this, right? If I want to use MySQL, I would have to basically make the change code, like change the code, right, to support this thing. Remember, Lisa says, how about C# developer? Yeah, I mean, I'll need to look into like if we have examples of C# because I'm not worked on C#. I probably will have to find some. But I mean, try to understand these things as like generalistic concepts, right? Don't worry about like whether this is an X language or an Y language, right? You probably might do it certain things differently, but the high level things remains the same, right? You would want to depend on generalistic things or abstractions rather than concrete things. Why? Because if you are dependent on concrete things, you would not be able to do dependency injection as such, right? You're bounded to this particular concrete thing. You'd not be able to change the behavior from outside. Okay. The next thing is, and this is the same thing was talked about in different ways. Like high-level modules should not depend on low-level modules. They should depend on abstractions, which basically means the same, right? If you think of high-level modules as like something very abstract or something very generalistic, right? Like an interface or an abstract class, they should not depend on something concrete or a low-level module, which is like a it's a child class or something like this, right? Or an implementation of an interface as such. They should rather depend on the interface or the higher level or the top level interface itself, right? Why? Because if you're not bounding those two restrictions, at any point of time, you'll be able to use it, right? And think of this, like why the name is called as dependency inversion. In general, the high level things depend on low level things. That's the dependency which we normally see, right? If you invert this out and saying that high level thing now depends on the high level things also, that's the dependency inversion as such. And that's the inverting thing, that you're not depending on low level things, you're depending on the high level things itself. And we're seeing like what I would say benefits it has, right? It gives us the flexibility of changing things when we have time. When we want to add more behaviors or we want to modify certain things, we are able to easily do that without making a lot of code change there and there. Okay. Let's take an example, and this example would be making it a bit clearer, right? So suppose you have an example of an application which uses a service, and there are ways in which you can do this, right? One is in the application itself, you can create that service, and you're dependent on like a concrete implementation of the service itself, right? You can do that and it will work, I would say. Or you can do something like this, where our application is dependent on a high-level interface of a service and is dependent on a high-level service factory, which is gonna create that service itself. So now what you're doing is you're not directly creating that service itself or the new instance of a service. You're depending on an abstract factory or a factory, or you can think of this as an interface, which is basically gonna have a responsibility of creating that service itself. And because now the application is dependent on the interfaces service and the interface service factory, right? So it's only depending on generalization or abstractions as such. It's not depending on anything concrete. It means that tomorrow, if I want to replace service A, which I was using right now, with service B, I could do that without any code change in the application itself. Now, if we look at this diagram and you can see this, there's a brown line which is going on, right? Everything on above this is basically like an abstraction or like a generalization, right? Like the service is an interface, service factory is also an interface as well. And everything which is below this is a concrete implementation, or you can say that it's a low level kind of a thing, right? Which is a concrete implementation of a service thing and a concrete implementation of a service factory thing. And because we like somehow all of those things, like everything is trying to be dependent, or like most of the things possible is trying to depend on abstraction rather than anything concrete as such, which means that it has this flexibility that tomorrow, if I want to change the concrete implementation of the service from this implementation to some other implementation, I can do that. And I can do the same for the service factory implementation, right? So tomorrow, if I want to create an object in a different way or some different form or something else, I would be able to do that without a lot of code change. Do we need to do some code change? Yes, probably yes. You cannot get away with, like, you cannot make modifications without zero code change, right? You would have to make some code change at some place, mostly, right? But this gives us the whole flexibility, right? Yeah. So this is what the dependency inversion principle is. In short, it says that at any place when you're trying to like depend on something, look at depending on generalistic or abstraction rather than something concrete. And if somebody asks you why would you do that, you just say that it gives you more flexibility, that in future, if you want to change something, you would be able to change that. You can have new implementations or different implementations going forward, and you would be able to dependency inject that, right? Also, right? You can inject that in some form and be able to use it. So you're not have to change the code of implementation or of that particular or like the place where you're trying to use this, right? You will not have to make any changes. You can make the changes from outside, and you can just say that, okay, now use this particular instance of this particular behavior as such. Okay, so we have done with these S.O.L.I.D principles as such, right? I mean, you can still go ahead and look at the examples which you have on the net. I would say, like, I've covered a few examples for most of these, and you can use these as an example, but I would say go back, try to comprehend this in your brain. How would you answer it in your own words as such, and then use it as such. And don't try to mug up these examples, I would say. This is where you generally land into trouble when you're trying to do all of these things in the interview. Try to find out, like, okay, if this is the case, why would this happen? What is the benefit and what is not the benefit as such? What do you save by building out smaller interfaces, by not having to, like, using broader interfaces instead of using broader interfaces as such? So think about all of those things. Yeah. Okay. Now going ahead from this. Yeah. So S.O.L.I.D is just a principle, and this is warning which I want to give you, right? A lot of time whenever we learn something new, we want to implement it, and we want to implement it to the dot. Basically saying that I want to see that everything I'll be able to do that to the dot, right? For example, back in college, we were taught that inheritance is the way forward, right? Everybody should use inheritance wherever possible. Now we have seen that if you try to overuse inheritance, you can land yourself into trouble. You can have class explosions. You can have a lot of side effects. You can have a lot of code duplication also. So is inheritance bad? No. But should you use inheritance always? Probably no. Should you prefer composition at certain places? Yes, we should, right? So this is how it gets changed, right? So these are things which you cannot take it as a binary thing that yes or no. You'll have to take a call. You always have, in software engineering, it's all about trade-offs. You'll have to take a trade-off on, like, should I use like single responsibility principle to the dot here? Probably no, because I think this is also one thing which is mentioned here, right? Like, let's just read this out and just try to understand this. S.O.L.I.D design principles are principle, not rules. First thing, don't try to use it everywhere. Wherever you find this to be a good fit, remember those principles and try to apply those principles as far as possible, but not always. And don't try to force fit it into anything. Always use common sense when applying S.O.L.I.D. And I think that I'll agree to this. If all of these principles are intuitive enough for you to understand. Avoid over-fragmenting your code for the sake of SRP or S.O.L.I.D. And this is what I've seen. Like, SRP means different things in a different way, right? I think I've seen people doing it as like where you'll have only one function in every class. Just imagine if all your classes have only one function. How bad is it going to get? How difficult is it going to be, right? So it's not what it means. It means that the responsibility and the single responsibility is in the context. It can be for one class. It can be for a module also. So you'll have to keep that context in mind. when it is changing, why it is changing, and things like that. And then you decide whether you want to take it out into a different class or a module. And things like that. Right? And don't always try to achieve solid. Use solid to achieve maintainability. You basically, the whole fundamentals about using all of these principles is because you want to have your code more maintainable. So don't do it the other way around, because you're trying to use solid. You can make your code unmaintainable also by using solid if you follow the SRP principle in a wrong way, and you try to create too many classes, or you have a class explosion. You're not making a code more maintainable as such. So you'll have to take the trade-off. And last final thoughts would be, the purpose of solid is to make your code maintainable, easy to extend, and reason about. It requires spending more time and spend less time reading it, right? You would want to spend more time writing the code and less time reading it. But in general, it's very difficult because we all work in big code bases, I would say. But yeah, solid principles are principles, not tools. Always know your trade-off and use common sense. Solid is your tool, not your goal. Yeah. So your goal is to have a good code, maintainable code, extendable code. Solid is not your goal. I think we can end this. So thanks for joining. I had a great time talking to you guys and taking all the questions up. Please do join in tomorrow for the next session on the DSA part. Yeah. And yeah, thank you. Take care. Bye-bye.